Hi, hello guys. Today video is about 4-bit ALU which can perform addition, subtraction or division or multiplication. Anything it can perform. So let's start our designing. So first of all we have to design a mux. We all know the working of a mux, right? So that a mux can select the input according to our given selector lines, right? So we want to develop a mux first. One more thing, I forget it that I was designing this 4-bit ALU in Logisim. This is the best software where we can easily design the analog circuits. Okay. Now, first of all, in plexer section, select a multiplexer and change the input to 4-bit. We are performing a 4-bit ALU, right? So we have to take 4 bits inputs. Now take an input pin. There is the input pin. So by using these input pins we can give inputs to this mux. Actually our mux needs 4 inputs, right? So I just copy and pasted those one pin into 4 pins, and now this single pin is converted into 4 bits. We are performing 4-bit ALU, right? So single pin will be converted to a 4-bit, so that in this pin section you can change the input bits to 4. See, there is data bit 1. We have selected 4. Actually, we are doing 4 bits, so we have to take 4-bit inputs. Now, and also we have to take output, right? So I also taken one output and one selector lines. See here, this is our output, right? So I changed it to output yes, so that we can able to see the output in that pin. Now, basically, what is our aim? Our aim is to perform addition, subtraction, and multiplication and division, right? So we have to take those adder, subtractor, and multiplier and divider from these arithmetic gates. Here, I have already done. So like this, you have to take those adder, subtractor from the arithmetic slide section. Now, what we have to do? We have to give a 4-bit data inputs to these adder, subtractor. Now we know that each adder or subtractor can perform subtraction or addition in two inputs, right? So we have to give two inputs, that inputs are of 4-bit inputs. Okay, see, like this you have to give connections. Okay, see here, you have to give those two inputs, that 4-bit two inputs to all these 4 adder, multiplier, and those are the circuits, right? So you have to give those two inputs to all the circuits, and those 4 outputs to a mux. Okay, and we have to check that output, right? So we have to connect an output which we have done in before, same like that output we have to connect in the output of a second mux. And selector lines, actually I had forgotten that for a 4-bit input mux, how many selector lines are there? Two selector lines, right? So you have to change that selector lines to a 2-bit input, 0 0.
Here
Okay,
I have given 3 bits. Actually, in the first of this session, I have selected 3 bits, so I given 3 bits. It's not a
now we
problem.
have to verify it whether the connections are correct or wrong. Now see here, I have given selector lines 0 1, right? That is 1 means the subtractor will selected, and the a bit is 1 and b bit is 6. If we perform in bcd subtraction, we will get 1011 means it's 11. Now we will perform addition, so that if we want to perform addition we will select I0, right? So that we will change that 1 to 0. Now it will change to 7. 6 plus 1 7. Like this way, yes, you can verify anything that 4-bit, like how many 4 bits, yeah, 0 to 15, right? So in these numbers we can perform anything. Like if you want more number of bits, like 4 5 bits or 6 bits, you can generate it very easily by giving simply the data bits to 5 or 6, whatever you want. Okay, yeah, I hope you will learn something new in this session. Until then, bye bye, tata.